setting multiplier. So here the clock setting multiplier is 4. So if the clock setting multiplier is 4, then it will take some time from this point to reach from this point to this point. So the time taken by this arm or this relay to reach from this point to this point is the operating time. So obviously it depends on the PSM. And the relay is so designed the relation will be like this. As the clock setting multiplier increases, the time taken by the relay to operate will decrease, obviously. More the clock setting multiplier means more the current is flowing to the relay coil, it will create more torque. So the time taken by this person to reach to that point will be less. But suppose if we increase the PSM, then it will be seen the car will be like that. And when the PSM is more than 20, then it is seen that the time taken by the relay will be more or less constant. So that characteristics is known as the IDMT characteristics. IDMT means inverse definite minimum time. So this minimum time, so characteristics is inverse, obviously, and it has a minimum definite time. So there must be some minimum time if you increase the clock setting multiplier, and it is seen that beyond this point 20 clock setting multiplier, the time taken by the relay to operate is same. Okay, so for this case, suppose 2 ampere current is flowing, means fault current is 1000 ampere, then 4 is the clock setting multiplier, and from this card, and this card will be specified by the manufacturer of this relay. So if it is 4, then from this card we can get what will be the time taken by the relay to reach from this point to this point. So we will get some value here. So this is the operating along y-axis, it is operating time, and along x-axis it is PSM. Okay, now there is another scale which is known as the time scale. Suppose here for 4 PSM we are getting time, suppose it is say 8 seconds. 8 seconds is the operating time for PSM 4. Now see one thing here, another scale is there which is known as the time scale. It is set at 1, means 100% setting. So this result 8 seconds is obtained if the time scale is set at 1 or 100%. Now what is it? Now how it can be varied? So basically, if I want the time taken by the relay should be 4 seconds instead of 8 for 4 PSM. So what can I do? We can advance this arm at the half of the distance. So how it can be? So this is a this is a stop band. So there is a rod, so it cannot move beyond that. So how this time scale can be adjusted? If we move this stop band, this rod where this possum is being rested, so it can be moved forward. So if I move it here, then obviously the initial position of this rod will be here. So it will take less time to reach from this point to this point. So I can, for the same fluctuating multiplier, I can adjust the position of this boson. If it is made 0.5, then it will take 4 seconds instead of 8. We can advance it further. Suppose it is say 0.25. So the 0.25. So it will be, instead of 8 or instead of 4, it will be 2 seconds. So the time scale is divided into this way, into those values. So 1 to 100% can be set. Okay. Now, if the fault current, let us take another example. If the fault current, say, uh, let us take another example for another time. Suppose the time has been set at, time setting has been set at say point, say 4, means 40%. So suppose the position, initial position of this arm is like that. Initial position. So it will take less time for any particular fluctuating multiplier. Now, if I if I ask you, what will be the operating time if the fault current is, suppose if the fault current is 5000 ampere, 5000 ampere, and plug is set at say 2 ampere. Plug is set at 2 ampere, means this pin is being inserted this position. So the less number of turn is being used here. Okay. Now, and it is, the time is set at 0.4. Plug is set at 2 ampere. Then what is the time taken by the relay to operate? That is the question. Now to solve this problem, what is done? If it is 5000 ampere flowing in the primary side or in the main circuit, the city secondary side current will be 501, so 5010. So 10 ampere current is going here. Okay, 10 ampere current is going in the secondary side. And the plug has been set at 2 ampere. So it is 10 divided by 2. So what is the plug setting multiplier? PSM is equal to 5. PSM, now the PSM equals to 10 divided by 10 divided by 2. That is the 5. 5 is the PSM. Okay. Now go to this curve given by the manufacturer. If the 5 is the PSM, if the 5 is the PSM, suppose the operating time is, say operating time is say 6 seconds. 6 seconds is the operating time for 5 PSM. Okay, so theoretically we can see 6 second operating time. Obviously, when the time setting is 100%. So the only curve that is provided by the manufacturer, the only curve provided by the manufacturer, the characteristics provided by the manufacturer is for the time setting of 100%. Okay. Ah, okay. For 100% setting, the characteristics will be given only. Otherwise, the manufacturer should provided should provide all the curves for all the time setting. It's not required. So it will give the manufacturer will give you just a single curve or single characteristics, and that is for 100%. Then we can calculate the time depending on this time setting. So as we have set it 0.4, so the theoretical time taken by the relay, it should be for 5 clock setting multiplier, we got 6 seconds, and it is set at 0.4. So 6 into 0.4 is the 2.4 second. So the relay will operate at this time. So the operating time is 2.4 second as it is set at 0.4. Had it been set at 1, then it would be 6 seconds. As it is, the time is set at 0.4, it is 2.4 seconds. So it should be the theoretical value. Okay, but in case of if we do it practically in lab, it may be 2.3 or 2.46 like that. There may be some error due to different factors. Due to the different factors means there may be error due to this spring. Then dust may be there in the bearing. This is dual bearings. Okay, that will oppose the movement of this spindle. So in this way, the overcurrent relay works. Okay, and one thing here, it is, you can see this thing. There's a magnet which is used for the damping. So for the smooth movement of, to provide the smooth movement of this disc, this magnet is used. Okay, if there is any movement, then it will oppose that movement, and when it is steady, then it will not oppose any force on the disc. Okay, so it is the operating principle of the current relay. Okay. So let us stop recording.